Welcome to the HFWorks video tutorial on resonance analysis of an air cavity. The model consists of three parts built in SOLIDWORKS: a cylindrical cavity, a dielectric body, and the air inside the cavity that surrounds the dielectric. The analysis will be performed by removing the metallic cylinder to reduce the computation time. Once the building phase for any SOLIDWORKS model is complete, you can click on the HFWorks Manager to begin the analysis. To begin the analysis in the HFWorks Manager, create a new study and select the study type needed. In this case, a resonance analysis is created and the first 5 modes of the structure are studied. The first step in the pre-processing is to assign the materials to all of the bodies. Properties such as the permittivity and the permeability can be assigned using an expandable library that includes materials provided by HFWorks and others created and saved by the user. These properties can also be reviewed and modified in the study itself. The next step is to assign the boundary conditions from a list of loads and restraints. In this case, the faces of the air that touch the metallic cylinder are given a perfect conductor restraint. In the last step of pre-processing, the finite element mesh must be generated. The mesh plot can also be reviewed along with other inputs before running the analysis. The mesh can be plotted on the surface of shown parts, or as a 3D plot displaying all of the finite elements inside a body. This 3D plot has the same post-processing capabilities as plots for the electric and magnetic fields. You can review the results produced for the design, which include the frequency of each mode, as well as the quality factors and the stored energy. For each of the modes studied, a 3D plot of the electric field can be viewed in different forms, such as line plots, vector plots, and continuous plots. To view the fields inside the structure, a variety of post-processing tools are available. Isosurface clipping can be used to truncate certain parts of the field plot to make the information more relevant. The field plots can also be animated to illustrate the variation of the field with the phase. The same features are also available for the magnetic field plots. Here, a vector H field plot will be cut using section clipping, which can also be applied on the fringe plots. The plane on which the section is applied is selected. The vector plot has a group of settings that allow for changing the manner in which the plot is displayed. These settings include the shape, the size, and the density of the vectors. Finally, after all the results needed are generated, a report can be produced to compile the results into a file. The report can be produced as an HTML document or a Word document, and can contain pre- and post-processing data as selected by the user. It can also be previewed inside the SOLIDWORKS environment. For more information on HFWorks and other tools provided, visit our website.